So first thing to talk about is the fact you might have noticed last night in Canvas, something changed about the way you submit your homework, right? Anyone notice that? It will not let you submit a JPEG. A picture, an image. So you have to submit a PDF. If you don't know how to submit a PDF, I can show you how to do it with an iPhone. We talked about this in the beginning of the year. I asked you guys to use PDFs and it was about half and half. But over the space of this year, I think people have gotten to use the Canvas scanning feature because they find that easier. And my job is becoming very difficult. If you guys load up 6 pages of individual pictures, I have to click on each one, load it up in my browser, activate it to read it, then close it down, click on the second one and open 6 individual pages. Rather than a PDF, I can just flip through really quickly. So I'm going to go back to requiring you guys to use a PDF in your submissions.
Is that when you do like the notes?
Yeah, with the notes button. So I'll show you quickly how it works. In the event that you want to create a PDF, please look up here. If you're using an iPhone, for example, use the notes feature, but instead of just clicking on it, click and hold on it, and it brings up a short menu, including scan document. When you press scan document, it'll allow you to take your phone into a photo position and take a picture of your page. I suggest you turn off the auto, and then you can take the picture you want to take. And if the image isn't exactly what you want, you can drag the corners to get the image you want. Then you press keep scan. It'll give you a chance to take another picture. And again, adjust as necessary, keep scan. And when you're finished, you click on save here. And now you've got a PDF that contains all the pictures in one. If you hold your finger on it, you can rename it to make your files match better and say Geom homework 78 or whatever. And then if you're using the Canvas app, you can share it and simply add the Canvas app there to share directly. So it will. So that's the process. If you need help with that, please come back and talk to me and I'd be happy to help you with that more. Question, Josh? I don't know. You can look for it. I didn't. All right. For today, I'd like to begin with what the word mean in mathematics means. You guys know what it means to take the mean of two numbers?
Average.
Okay, good. We often think about it as the average. And so if I were to take the mean of these two numbers, what would you get? Close.
817.
Third guess was right. How do we do it? Add them together. So 2 plus 32 equals 34. And then divide by, because there's 2 of them, we divide by 2. So it'd be 17. Now here's the harder question though. What does it mean? What does that number mean? What significance does it have? Yeah, well, that's what it says, but what does it mean? Colin? A little more specific, because there's a lot of numbers in between 2 and 32. Good. If we put 17 here, I have to add 15 to my starting number to get to 17. And if I add 15 again, I get up to 32. It's the additive middle, so to speak. Well, it turns out you guys have been fed a bill of goods that's only half true. This is not the only mean. This is actually called the arithmetic mean. And today we're going to be learning about something called the geometric mean. Now, to do this, before we get into this, I got to do a little bit kind of background stuff. You know that if I have, for instance, 2 outside of a parentheses containing x plus 3, that I can distribute this, right? And I can say 2 times x and 2 times 3. And I would expand this to be 2x plus 6. Agreed? And if I were to have something like x squared y to the third, and I raise that whole thing to the 5th power, what does that simplify to? We multiply these. So x to the 10th, y to the 15th. Sounds like we need a little algebra review on that too. But what if I were to say like x plus 3 squared? Is that x squared plus 9? Oh, we need a lot of algebra review.
No, it's x plus 3 times x plus 3.
Right. It's x plus 3 times x plus 3, which means we do x times x times 3, 3 times x, and then 3 times 3. And overall, we get x squared plus 6x plus 9. In other words, we were not allowed to distribute this 2, the squared, across this addition. Why not? Well, I'd like to ask if I were to tell you that I wanted you to add 7 5s together. 1, 2, 3, 4, 5, 6, 7. Would you do it as an addition problem? Would you say 5 plus 5 is 10 plus 5 is, no, what would you do? 7 times 5 or 5 times 7, because you know that repeated addition is really just multiplication. And similarly, if I told you to do, I don't know, 13 times 13 times 13 times 13, you would call that 13 to the 4th power, because multiplication, when done repeatedly again and again and again, becomes an exponent. So I'd like to suggest that arithmetic, adding as an operation is the simplest of operations. And if I step it up a degree to like multiplying, it's kind of like turbo addition, right? You do it again and again and again, it becomes multiplying. And similarly, if you do multiplying again and again and again, you get exponents. And so the reason why we're able to do this 2 times the x plus 3 is that multiplication and addition are 1 degree apart. So it's okay to distribute this across that. Similarly, I can do this problem because exponents and multiplication are 1 degree apart. But the reason I can't distribute this one and have to instead do it as a long problem is because exponents and addition are 2 degrees apart. They're too far away from each other. You with me in concept here? 5, I'm right with you. This all makes perfect sense. 3, I'm sort of getting what you're saying. I'm not quite sure why you're saying it. 1, you telling lies. Good. So what I'd like to suggest is that just as multiplication is turbo addition, what we're going to be doing for the geometric mean is like turbo arithmetic mean. So instead of taking 2 and adding 32, what do you think we're going to do? Good. Multiply. And 2 times 32 is 64. Now for the arithmetic mean, we divided by 2. And let me describe what that did for us. We added 2 numbers together to get 34. By dividing by 2, we said, okay, I understood we added 2 numbers together, but what if those 2 numbers had been the same number? What would that number have to have been? And the answer would be 17. So here we're saying these 2 numbers were multiplied together. What do we do to 64? So we find out what the number would have had to have been if it had been the same number times itself. It would be 8, which means what do we do to 64? Yes. Square root. And can you visualize how that is kind of a turbo division of sorts? So at the end of the day, what we're getting out of this, and you'll see on the sheet in front of you that you have an opportunity to practice the geometric mean this way, is down here on the bottom. I want you to take this cell at number 5, 6, and 30, and we're going to find the geometric mean of that. The way we're going to do it is we're going to multiply those two numbers together, 6 times 30, and then we're going to take the square root of that. And let's clean that up. The 6 works because I can factor 30 to become 6 times 5. And who's pairing up? The 6's. So I bring that outside as a single 6, and the 5 is a prime number left on the inside. So 6 root 5 is the geometric mean between 6 and 30. Would you please do 6 and 7 yourselves? Go. Check your answers here. You should have gotten 8 root 7 and 10 root 6. I sure don't remember you multiply. I don't suggest you take 16 times 28 and get a big number, because you're only then going to divide it down anyway. So you may as well start factoring right away. Yeah, Braden?
Wait, so what do you like the second one on number 6?
If you did 7 times 4, then you've left 4 without factoring it down, and you're going to get 4 left on the inside. But 4 is 2 times 2. So you can factor it down to its prime numbers and pull it out as a 2. I could have taken these 16 down to the 2 times 2 and 2 times 2. If you take it down to its prime numbers, it'll always get you right. I'm being a little bit more advanced in my maneuver here by recognizing that I can take out a 4 because these are both bigger. But don't forget to take all those other numbers down. Okay, 5, doable. I can calculate the geometric mean between two numbers. 3, I sort of get it. I'm going to need some more practice, and I'm sure going to need some notes or something to remind me of this process. 1, I'm confused. What's that little house doing there? Okay, good. Now, I'm going to ask you to just kind of put that on pause for a second. We'll come back to it. And tell me what you notice about this triangle up here. What are some features that we can identify? Kenyon? Okay. ABC is a right triangle. You guys agree with that? So I'm going to come over here and I'm just going to write triangle ABC. What else is in the picture? BDC. And what do you think is true about triangle BDC? It's also a right triangle. And what about ADB? Also right triangle. So these are 3 right triangles. Does that mean they're congruent? No. Do they have any relationship? We don't know. We know they're right triangles, but do you agree we do not know what this angle measure is here? I'm going to pretend I do, and I'm going to put in a little symbol and call it, this is angle is worth star. Okay. And this angle over here at C, would you agree that that is not necessarily the same as star? So I'm going to put a different symbol there. I'm going to put circle there. And what I'm telling you then is that star and square, the right angle symbol, and the circle all add up to how much? 180. Now, you'll notice that triangle ABC has star, square, circle. Triangle ADB has star and square. So how big is this angle? It has to be circle, doesn't it? One of the corollaries of the triangle angle sum theorem was that if two angles of one triangle are congruent to two angles of another triangle, then the third angle must also be congruent. So if this is also a right angle here and this is a circle, what's this angle up here? Star, because those three add up to 180, these three add up to 180, and those three add up to 180. Given that, can we say something more about the relationship among these three triangles? Are they kind of alike? Similar, excellent. Why are they similar? Good. These triangles are similar by angle-angle similarity. And if I want to write the similarity statements here, triangle ABC, so star, square, circle, would be similar to what triangle for the medium size? Is it ABD, ADB, BAD, DAB? Star, square, circle. So star, square, circle, ADB. And then that would be similar to star, square, circle, BDC. We all okay with that? These three triangles produced, when I start with the right triangle and I build an altitude straight down to the hypotenuse, they end up being all similar. Now, what's interesting is, let's do that again over here. I'm going to call this star and this circle. This is my right angle. So if this is star and this is a right angle, then this is my circle. And if this is circle and this is my right angle, then this is my star. And what I'm going to do is I'm going to draw the three triangles. And I'm going to draw them in such a way that they're kind of oriented the same direction. So they've all got a right angle there. And they've all got a star on the top. My drawing is very rough here. And a circle in the bottom right corner. So in a big triangle, how would I label it? What letter goes on top here in the star? P. What letter is the right angle of the big triangle? Q. And what letter is the circle in the big triangle? R. Okay. Now let's use the medium triangle, this one over here. The star is P. Nope. Middle triangle. S, then Q, and the little bitty one, star, right angle, circle, so Q, S, R. Why is it valuable to orient these this way, to spin them around and flip them over so that they're like this? Yeah. About what? What are we? Yeah. And also, are these triangles all similar? They are. And so if I were to say, for example, that the left side here, would you guys please be quiet? The left side here could match to what other side? Maybe QR? Let me just. So if I take PQ and create a ratio between the left side of our triangle and the bottom of our triangle for the biggest triangle, what could that be equal to as a proportion? PS over SQ, and also as to right. These are all the similarity statements, the proportionality that we were able to create with similar triangles. Given that, we should be able to see a relationship. For example, in this triangle, I want to solve for x. So I'm going to say x over something. How would you describe x? Is it a leg or is it a hypotenuse? Okay, are we talking the smallest triangle, the middlest triangle, or the biggest triangle? Middlest. So you're talking about this triangle right here, and you're saying it's a leg. Okay, you guys all see it that way? So if he's talking about the middle triangle, which leg is it? Yeah, but that changes visually. Can we agree that it looks like the smallest one? I know we're going by looks. But if it were drawn to scale, is that the small side? Okay, so we're saying that the middle triangle, small side is x. So if I want to create a proportion, what goes down here? It's got to be part of the middle triangle, right? Yeah, it would have to be the hypotenuse of the middle triangle, wouldn't it? So we'd have to put 12 there. So now we're saying hypotenuse. And that means that over here, we have to have the hypotenuse of one of the triangles. Should we use the smallest one? Should we say 9 there? But if we did that, then we wouldn't have this missing piece to go up there, would we? We wouldn't have the smallest side. So what if we do the big one? We say 15 is the hypotenuse and the smallest side is 9. Does that give us a matching pair? Smallest to hypotenuse, medium triangle to biggest triangle. And once I get the proportion, it's cross multiply to solve. 15x equals 9 times 12. Divide by 15, divide by 15. Use my little calculator, and I get 7.2. I would say there's 3 components to this problem. Step 1, do you recognize that when you have a right triangle and you create an altitude to it, that it creates 3 similar triangles? Step 2, once you identify that they're similar, how do you create a proportion out of those? How do you find the matching parts? And then step 3 is once you've got the proportion, can you solve it? What's the hardest part on this problem? 1, 2, or 3? The hardest part is to know that they're similar or to find the proportion out of it. Yeah, and then cross multiply. So that makes sense because we worked on finding if triangles are similar first. We did cross products once we knew triangles were similar. And so now what we're discussing, this unit is all about similarity in right triangles. So that's what we should be finding. That's the hard part. Let's try it again on number 3. We're going to create a proportion. I know I got to have x. So what's my proportion? X is to what? Okay. I like that. You're doing small to hypotenuse in the middle triangle again as what? What goes over here? Sorry, a little clearer. You guys agree? It's the smallest side to its hypotenuse as the smallest side to its hypotenuse. And then we can cross multiply and solve. 23.8x equals 11.2 times 21. So x equals 11.2 times 21 over 23.8, which is equal to 9.9. It's actually about 9.9. Okay, please try number 4 yourselves. All right, 5, I can do this. 3, I may have a shot at it. I might have a little trouble getting those proportions together, but I think I'm good. 1, this is hard for me. Okay, now let's flip to page 2 for a second. And go right in the middle here where it says geometric mean leg theorem. What you guys did is you basically said that this little thing is to the hypotenuse. This little thing is to the hypotenuse as this little thing is to this hypotenuse, right? That worked well for what we were just doing. But there are other matching pairs. For example, let's say I do this all out. Let's say I create a right triangle, and let's go A, B, C. Does that sound familiar? I'm going to drop down this altitude, and in the process, what's produced is I'm going to call this an H, because it's the height, and I'm going to say that these two parts have been split into X and Y now. You guys with me? We all agree these are similar triangles now. I'm going to put in the circles and the stars so that I can keep track of which parts go where. And I'm going to draw my 3 triangles, my papa bear, my mama bear, and my baby bear. And I know that this assumes that there is a nuclear family that is a male and a female, and that the male is large and the female is middle. And I'm not really going there. I don't believe in that, but let's just go with small, medium, and large. And this triangle, I'm putting the star on top and the circle on the bottom, and the star on top and the circle on the bottom, and the star on top and the circle on the bottom. How will I label these 3 sides? Opposite the star in the biggest triangle is what letter? Opposite the circle in the biggest triangle is B, and the hypotenuse is C. What about the middleist triangle? What's the side opposite the star in the middle triangle? H. What's the side opposite the circle in the middle triangle? Well, because we're trying to fill in the missing sides of all the different triangles. Just kidding. Okay, what about the hypotenuse of the middle triangle? B. Littlest triangle, what's opposite the star? X. What's opposite the circle? H. And the hypotenuse is A. So I'm going to say that I want to solve for A. And I see there's another A over here. So I'm going to use those. I'm going to say that this A is to X as what? As C is to A. You guys all buy that? All right, now I'm going to cross multiply, and I get A squared equals C times X. And then I'm square rooting both sides to solve, and I get that A is the square root of C times X. Okay, let's just leave that alone for a moment. Try another one. Let's do B. What would be a good proportion to set up for B? B is to Y as C is to B. I like that. And again, they cross multiply, and I get B squared is equal to CY. So B is equal to root C times Y. One more. I want to do the H. So H is to what? Can we do H is to Y as X is to H? Does that work? H is to Y as X is to H. Cross multiply. Seems like a lot of math for no help. Why is it important that A is equal to the square root of C times X? What do you call it when a number is equal to the square root of the product of two other numbers? What does it mean? What does it mean when a number is equal to the square root of the product of two other numbers? It's the geometric mean, isn't it? What we started with? Remember this whole discussion? Geometric mean? You did this on page 1 where you just took the square root of their product. So what this says, what this tells us is that when we have this scenario, a right triangle with an altitude dropped to the hypotenuse, that we can actually create side length relationships that are the geometric mean. And you guys have figured out by now, I'm a visual kind of person. So what I'm going to do is I'm going to color this side yellow. I'm going to color this part red. And I'm going to color this part blue. So if I'm looking at A down here, A is a geometric mean between C and X. So I'm going to use which colors to solve for A? C is blue, X is yellow. So A should be what color? Green. Because it uses yellow and blue, right? What about B? B comes from C and Y. Well, C is blue and Y is pink. So what color will B be? Kind of purplish. Red and blue is purple. And H is the square root of X and Y. What happens if you mix yellow and red? So if you've got the ability to use colors in your notes, this would be very helpful. I'm guessing most of you don't. So let me show you a different way to think about it. On your second page here, you see this triangle. What I'm telling you is that this right angle is the inception point. Everything starts from there. How many legs come out of that angle? 3. And each of them that comes out is the geometric mean of something else. BA. Do you agree that BA comes out of that right angle? And what point does it end on? What's the end point of BA? A. What other two segments end on BA, on A? DA and CA. Those are the two that are the components of the geometric mean. DA times CA. What about BC? That comes out of our inception angle. And it ends on C. What other segments end on C? DC and AC. The right-hand part and the whole thing. And lastly, BD. BD ends on D. What two segments end on D? AD, AD and CD. So let's say that we're going to do problem number 12. We're going to look at our inception angle, the right angle in the corner, and we're going to say which one is coming out from that I care about. I see X over here. So as X comes out here, it reaches this endpoint. Since it's coming out of that right angle, I know that's the answer to a geometric mean problem. And which two segments also have this same endpoint? Well, 24 does. I would say 2 doesn't. 2's over here. It doesn't end there. But what about this whole length, including 24 and 2? So 24 times 6 does, doesn't it? So then we can simplify that. 24 is 2 times 2 times 3 times 2. 26 is 2 times 13. So 2 pairs up, another 2 pairs up. That means it's 4 square root of 39. All right, what about number 13? Which one's the one coming out of our inception angle at the corner here? X. So that's the part that's going to be x equals. And it's going to be the square root of a couple of numbers. What parts will it be a square root of? I like your answer of 12 because that's a segment that ends at the same endpoint here. But I don't think 19 falls into this equation at all. Where's the second segment that ends there? Or how big is it? 5. Right? If 12 is the whole length and we're using 7 for this part, isn't this part 5? And that's another segment that ends at that same piece. So 12 times 5. 2 times 2 times 3 times 5. 2's pair up and it's 2 root 15. Okay, let's take a look at number 8. Go up a little higher. Which is the leg coming out of the inception corner? It's x, right? So x equals. And what are the two numbers that share an endpoint with the endpoint of this segment known as x? 8 and 12. So this would be 4 times 2 times 4 times 3. 4's pair up, so it's 4 root 6. What about 10? I know it's going to be something equals square root of something. What goes here on the left by itself this time? Good, because coming out of here is the side marked as 18. And 18 ends there, which means what two parts go inside here? 15 times x. This one's going to take a different process of solving that. How do I get in there to get that x? Yep, square both sides. 18 times 18 is 324 equals 15x. Just makes the square root go away. And if I divide both sides by 15, I get x equals 21.6. Nice precise answer. There's no rounding involved. All right, this is your work for today. You've got 4 sides total. I've done just about 2 of them for you. Finish this up here in class. If you haven't yet taken the unit test to a point of satisfaction, this is a good day for that as well. It's almost 3 o'clock, so we have about 45 minutes. Come on up here, give me your phone, tell me you want to take the test, and I'll set it up for you.